So, what is a parametric equation? Well, parametric equation defines a relation using parameters. One example is when one uses a time parameter to determine the position, velocity, direction, and other information. Here is a sample problem. Given x equals 4 cosine t and y equals 2 sine t. We can set cosine of t to equal something in x, and we can set sine of t to equal something in y. To do that, we divide both sides of the equation by 4. So you get x over 4 equals cosine t. To the other equation, you divide y by 2, so you get y over 2 equals sine t. We then substitute the two equations into the unit circle equation, which is cosine t squared plus sine t squared equals 1. And now we have the equation of an ellipse, which is x over 4 squared plus y over 2 squared equals 1. With the equation x over 4 squared plus y over 2 squared equals 1, we know the shape of the equation. The center is at the origin. The major axis is the x-axis. The x-axis vertices will be 4 units from the center. The y-axis vertices will be 2 units away. Go back to the original equations, which are x equals 4 cosine t and y equals 2 sine t, to find the direction. Let's graph it. As you just saw, the starting point was at 4, 0, and the motion of the ellipse is counterclockwise. For the motion to be counterclockwise, the motion will have to begin with the value of x decreasing and y increasing as t increases. Since one revolution requires 1 second, but the period is 2 pi over omega equals 1. So omega equals 2 pi. To increase the speed, you increase omega, and to decrease the speed, you decrease omega. If both equations are negative, it would start at negative 4, 0 instead of 4, 0. It would still be counterclockwise. So that means x increases, y decreases as t increases. For the motion to go clockwise, one of the equation would have to be negative. For it to start at 4, 0, the second equation would be negative, which is y equals negative 2 sine t. So that means x decreases, y decreases as t increases. For the starting point to be negative 4, 0, the first equation would be negative, which is x equals negative 4 cosine t. So that means x increases, y decreases as t increases. In this sample problem, we are trying to find the parametric equation of this ellipse. We know that the center is at the origin, and the major axis is at the x-axis, which is 3 intervals, and the minor axis is at the y-axis, which is 2 intervals. So we know the equation would be x over 3 squared plus y over 2 squared equals 1. And we know that cosine square t plus sine square t equals 1. So if we plug this in here, it will be cosine t equals x over 3, which would be x equals 3 cosine t. And sine t equals y over 2, so y equals 2 sine t, and these are our two parametric equations. For this problem, the ellipse motion begins at the point 2, 0. is clockwise and requires 2 seconds for a complete revolution. We are trying to find the parametric equations for an object that moves along the ellipse x squared over 4 plus y squared over 9 equals 1 with the motion described. But here is the graph of the ellipse. We're trying to convert it into the parametric equations of x equals cosine times omega t and y equals sine times omega t. We know that x over 2 equals cosine t and y over 3 equals sine t because the x-axis have 2 intervals and the y-axis have 3 intervals. When we convert it to this equation, it will equal x equals 2 cosine pi t. Where did this pi come from? Well, omega equals 2 pi in 1 second, but this is 2 seconds, so we divide by 2, which is pi. And y equals negative 3 sine pi t, and the time interval will be between 0 and 2 because it's 2 seconds.